I've been doing research out here, yes, I told you earlier, on horseshoe crabs for a long time, and my students came out, my undergraduate students came out and did research projects, and we did class projects and so forth out here for a number of years. And then I kind of wanted to, I had been working on wasps, and I kind of wanted to change that. I just felt like I had done a lot of the things that were interesting with that project, and I was sort of thinking about what I wanted to do, and I was interested in what are called alternative strategies, which are when for example, males have more than one way of getting reproduction. So they might, like in salmon, the males might sometimes grow to a large size and guard a nest and court a female, whereas other males mature very early and sneak into those nests and fertilize eggs. So those are referred to as alternative male mating strategies, and they're actually life history strategies of those animals. And so I was interested in that question, and I thought, well, I've sort of got that out here with these horseshoe crabs, because some males come into the beach holding on to the female, holding on to the back of the female, and some males come in and gather around a spawning pair. So horseshoe crabs come up to the beach, they come up to the top of the high tide line, and the female kind of buries down into the sand and lays eggs, and the male fertilizes the eggs externally as they're being laid. And so it's just little couples come in all up and down the beach. You'll get couples spawning right on the beach. And so some males grab a hold of females, and some males come in without females, and they gather around these spawning pairs. And we ultimately found that they are fertilizing a lot of the eggs that the females lay. So if the males, so the pair, there's a female in front and a male behind her, and there's a male right here and a male right here. Those are the males that don't have females. If they're right in those two positions, they can fertilize a lot of eggs. And so we determined that using genetic analysis, and so I thought, well, that's alternative strategy. So I put in a grant and got the grant, and so that's why I was doing this research project out here. And as I said, in the early days, I had some of my students out here, the undergraduates out here, but it ultimately became, they kind of got in the way of the project. You know, they would do things like tag animals and not measure them right and so forth. So ultimately we kind of gave up on that a little bit while the project was going on, and had them doing other projects around the island, other things on the island, because there are lots of animals that they can use that. So the eggs then develop in the sand, and the juvenile, there's a larval stage for just a short period of time. They swim out of the sand when there's an extra high tide, and they then, the juveniles, are nesting off this beach. So if the tide were to go out a little further than it is, you would see the little tracks of juvenile horseshoe crabs in the mud off this beach, and there are lots and lots of them. And so horseshoe crabs go through a whole series of molts, 9 or 10 molts. We don't know for sure for our population here, but they go through 9 or 10 molts, and those molted skins come up on the shore. And so I can actually see one down there. They missed. They come up on the shore, just float in, and so we've been trying to also do an analysis of the life history of the juveniles here. We don't really know exactly how. We all say that it takes 9 or 10 years, but they might develop more quickly here because it's warmer. We don't know that much about Florida horseshoe crabs. So So you have these little molted shells, and that you can find along the shore. And today I found quite a number of largish ones, which are nearly adult size. So they go through 16 or 17 molts before they get to an adult size. And this is an adult male who I think he just bit the dust here. I don't know what happened to him. He's a little bit old, but you can see that it's a male by these things on the front here. Otherwise, he looks like he's in pretty good shape. I was going to say a little bit more about some of the projects that the students did. So one of my students, Dustin Penn, did a project. So one of the questions, so the horseshoe crabs nest on new and full moon high tides. And those are the tides that come up to this level or that level there. When the tide is down here, they're not interested. They don't even come to the beach. And so we were curious about why that might be. Why do they? I mean, it's quite something to have this huge invertebrate practically climbing out of the water. And so we took eggs that had been laid here, and we moved them higher than they normally nest, and lower than they normally nest, and compared the developmental rates in those different areas. And so we found that the ones that were higher than they normally nest dried out, and the ones that are lower than they normally nest develop very slowly, and there's higher mortality down there because there's less oxygen in the sand and more hydrogen sulfide, which is poisonous to the eggs. And more recently, another student Christina Vasquez, has done another project kind of along those lines and comparing different sites as well. And she actually measured the oxygen level in the sand and so forth, and did a really interesting project on that, and looked at the differences in developmental rates under different oxygen conditions. So that was one of the projects that the PhD students have done. One of the projects that the undergraduates would do is one of the early projects is to compare the appearance of males that come in with a female and males that are nesting without, I mean, they gathering around the spawning pair. So there's males that are actually literally clamped on. They have these, males have these specially modified claws that are used to clamp on to the back end of the female. They clamp on right in these two spines on the female. So the little pair come in together. And so there are attached males, and then there's unattached males. And so one of the projects we would do would be to compare the appearance of, or the condition of the shell and the size of the animals. I figured probably the attached males would be larger because they'd won out, but that wasn't true at all. I had lots and lots of measurements of the sizes of attached and what we call satellite males, these other males. And they did not differ in size, but that was one of the projects that the students did. And then one day one of my students mentioned that the males look different, the satellite males look different. And so then we started recording the appearance of the shell. So the young animals are slippery and they don't have anything growing on them and so forth. And older animals lose that mucus secretion covering, and they have lots of stuff growing on them. And so we were able to compare it, and in fact, the attached males are, on average, younger than the satellite males. And that was something where we could get the data just in one class period, one two tides. We could get the data for satellite and detached males, sizes and condition, and then go back up to the lighthouse, sit there and analyze the data, make comparisons, do the analysis, draw the graphs, make up a poster, do the whole 9 yards right there. So, and then we had various other projects as well. So, but those were some of the main things that we have been doing. Then one of my graduate students, Rachel Schwab, and Cynthia did it before her also. We started doing, we were interested in how these males, so you've got all along this beach, you have pairs nesting along the beach. And these single males without a female cruise up and down this beach. And at some point, they turn in and come up on the beach and join these spawning pairs. And so we were interested in what kinds of cues they were using, what attracts them. I figured that it was a chemical cue, but we put out, Cynthia made cement molds, models, or casts, I guess is the right word, made cement casts of horseshoe crabs. I still have them. They weigh an absolute ton. And she tromped up and down this beach with these buckets full of these cement casts. And we put them right at the shoreline. And those males, those unattached males, satellite males, were very attracted to the, even though they didn't smell like a female, there was nothing attractive about them, they nonetheless were attracted to them. And if we put, another one of the students put a sponge that had water from a female under, so we had two pairs of these. We had a cement pair and another cement pair here. And this one had a sponge that had odors from a female that had been collected down a little ways. And the one with the odors, one with a sponge, and this one had a sponge, but just seawater. So the one with odor of the female was more attractive. So from this we knew that they were using both chemical and visual cues. That was another nice little paper that we had with this, and it was a master's thesis that the student wrote. That was Rachel. Yeah. So that was Dustin, Penn, and Rachel, and then more recently, my students have been working on. Matt Smith. This is quite a recent paper. He was interested in why is it that the old males are the satellites? Why are young females attached and old males satellites? And so we actually found this by accident. We took animals and put them into those little pools that are those little tanks that are down by the lab. And I noticed that so horseshoe crabs poop a lot. And I noticed that the tanks that had females and satellites in them, we put one in each of the tanks. Females and satellites, they pooped a lot, and the ones that had attached males in them didn't. So we then started doing the analysis on it, and that's exactly how it came out. And so these attached males are not feeding. And they might stay attached for 2 or 3 weeks, and they're not feeding. So our current hypothesis is that these males are, these young males can sort of afford to do this. The older males must feed in order to be able to produce sperm and so forth, I guess. And then I've also had another student who's worked on the differences in the amount of sperm that is produced by satellite and attached males. and the older males produce less sperm. And in fact, attached males produce more sperm. There's some other details on that, but anyway. So anyway, it's been quite an array of different kinds of projects. We've made a lot of progress in understanding the horseshoe crabs, and we still have a lot of questions to go, a lot of hypotheses, things that could be done. But it's been a great place for my students to work, particularly I mean, we've had several PhD theses. Matt and Daniel both did a PhD out here, primarily out here. But it's an especially good place for master students, so for students who just want to come out, they want to try out some things, they want to get a project underway. I don't know if it's still the case, but you used to be able to come out. If you were a zoology student, you could come out here relatively inexpensively and just be immersed in this wonderful environment and try out different possibilities, try out different hypotheses, work with different animals out here, the fiddler crabs or the, whatever they were interested in, and be able to get enough preliminary data to be able to write the grants, to be able to get the support that they needed to be able to do a project, proper project. So it's been an especially wonderful place for getting something going, getting projects going. It's not such a good place for doing really technical things. Like we were doing the genetic analysis. All of that was done in a lab in Gainesville.
Over the years, have you seen changes in the horseshoe crabs or their population?
Yeah, there have been a lot of changes. This beach has changed a lot.
That was my follow-up question,
okay.
Is the changes over time to the island?
Yeah. The horseshoe crabs, we, just because I like data, I guess. I don't know why I started doing this, but, well, there were reasons. So I survey every time we come to the beach at the time of the maximum high tide. I have at least one person walk the beach and survey the number of animals on the beach and the sex ratio on the beach, because I always had the idea that behavior might be changing depending on density and sex ratio on the beach. And so we have these surveys that go from 1990 up to 97, and then I have them for 2003 and 4, and then 7, 8, 9, and 10, and then 14. So I have this, 17 years or something of surveys out here. And the numbers of horseshoe crabs were very consistent early on. Year after year, they were very consistent up to about 2000. Now, I wasn't coming out every year at that time, but roughly 2000. And then the numbers increased dramatically. And I really don't know what was the cause of that. I have various hypotheses. One of them is that that's the period in which the clam farming started. Mm-hmm. And where they had after the net ban, and the horseshoe crabs used to get caught in the nets all the time. And in fact, you can see from our data that the animals are in better shape now than they were in these early days, because they lose legs, and because they just would pull them right out of the nets, and it was very hard on them. So maybe it was the nets. Maybe horseshoe crabs eat clams. And juvenile horseshoe crabs, the little bitty ones, little tiny horseshoe crabs, will eat clam larvae. So one of my hypotheses is that they did better because of the clam farming. I've talked to Leslie Sturmer about this, but I don't know how to test that hypothesis. But anyway, and then in 2014, when we were out here, the numbers were back, not down to as much as to where they were in the 90s, but they were back down a little bit. So I'd really like to come out again and do another field season and actually determine whether the numbers are up or down. So I think they're going back down based on what I've seen at Cedar Key. I think they're probably kind of back what they were in the late 90s. the island itself has just changed remarkably. I mean, the beach is smaller. I mean, we still have a beautiful beach here, but that's only because all the sand from up here is eroding down onto the beach. So it's but it is much smaller because I know, for example, this has been here for many, many years. This I think was the '83 storm, which took out the stairs as well.
83 or 93?
Oh, sorry.
Storm of the century?
Yeah, storm of the century was '93. Excuse me. Yeah, '93 was the storm of the century, which took out the stairs, and it might have been what made this. I'm not sure. But there used to be much more sand. The beach used to be considerably wider than this. And then there are some things like down a few hundred yards, down it's kind of where it bends, down the bottom, there used to be a Indian midden. And you would just come along, there'd be big conch shells, you know, big queen conchs and whelks and so forth, and they'd have holes, you know, that obviously they had been eaten by humans, and that is completely gone now, and that completely eroded away. These things, there's been a huge amount of erosion this past year with the storms that we've had this last year or two, I would say. All of this stuff has come down. These palm trees down here come down, and these used to be. They used to have sand around them. There used to be. So it's the beach is considerably smaller than it used to be, and the island is gradually eroding away. But that's in the nature of islands in the Gulf. They move. The sand is going somewhere and probably piling up somewhere else. So it's just in the nature of things. But this is a special island because it is so high. It's an old sand dune from a time when the sea level was very much lower. And so it has all these oaks and bay trees and so forth growing on them. So it makes it quite different from everything else. We used to say that this was a major place where the birds were nesting and that they wouldn't nest anywhere else. But of course, that turned out not to be true. So anyway.
Well, thank you, Jane. Is there anything else that you would like to add while we're down here?
Can't think of anything. Let me take a look at let's see if I've covered a lot of the things that we have done. Nest site selection, and yeah, I've taught you about the age and the paternity analysis that we did, and the chemical cues. Yep. And then we've done an analysis. Also, I worked with some other people and done an analysis of horseshoe crabs in here and in various places around Florida. Some collections that I've made and other people have made. And the horseshoe crabs occur in genetically distinct populations around Florida. So there are at least 5 genetically distinct populations. So the animals in New Smyrna Beach, St. Augustine are different from the ones in Indian River. They're different, completely different from the ones over on this side. There's some difference between here and Tampa and here and St. Joe Bay. So these are just genetically distinct populations, which is one of the reasons that it's really interesting to get some surveys so that we know what the status of all these different populations is. And then this is why in the last few years we've been trying to get a citizen science project going, and one of our citizen science sites has been here at Seahorse. And there's always nearly fights amongst our volunteers as to who gets to come to. You always get to come to Seahorse. We want to come to Seahorse. So everybody wants to come out here. And indeed, I don't blame them. I do too. Yeah. And then we've just finished a paper. It was just published like last week in which we've done some modeling. I worked with two other people in the department, and we've done some modeling of the male behavior and sort of how males, sort of using the data that we have, little bits and pieces of the data, we modeled what rules, sort of the minimum number of rules the animals would have to use to be able to find their mates, and that kind of revealed some interesting results as well. So it's an interesting experience. All right, I guess that covers most of the things I wanted to say.
Thank
I would
you,
say,
Jane.
yeah.
We surely
Got
appreciate
the
you coming
species
out.
covered. Yep, I did. Got those wasps, pelicans, and antlions.
Yep. Well, thank you
All
so
right.
much,
Yeah,
Jane.
you're welcome.